All right, this is section 13.3, types of reactions. We're just going to cover the first half, or first part of this section here. And the objectives will be to be able to describe what's occurring in synthesis and decomposition. Those are the two that we're going to get into in this part of it, and to be able to classify those, the synthesis and decomposition, and predict the products of some simple reactions. Later on, we'll get into single replacement, double replacement, and combustion. That'll be in part 2 of this video. Alright, first of all, what is a synthesis reaction? Well, think about what the word synthesis means. Synthesis means to put together. And so when we're talking about a synthesis reaction, we're going to take two or more reactants and we're going to form one product. So we're getting one thing. It's going to combine them together. Sometimes this is also was called a combination reaction, be another name for it. So it's going to look something like this. You're going to have product A, reactant A, reactant B, and you get one product put together. Typically, a lot of times these are elements. They don't have to be. They can be small compounds that are put together and a bigger compound here. So here's a good example. If I have some hydrogen, two hydrogens, 2H2, and some oxygen, when I put that together, I get two waters. So this is an example of a synthesis reaction. We started with two reactants, one product. So the key when you're looking to try to identify these is the fact that there's only one product. That's what's unique about this synthesis reactions. Alright, you should be able to write the chemical equation for synthesis reaction just by knowing what you're trying to find. So in this example, I'm trying to find or make sodium chloride. So, what do I have to start with? Well, I need to start with some sodium. I need to start with some chlorine. I need those two things in order to do this. So put this stuff in here and then write the equation. Well, sodium. Well, what is sodium? Is it a solid, liquid, gas? Well, sodium's a metal. It's a solid at room temperature. So we have some solid sodium, and we're going to take some chlorine. Well, chlorine's a gas, and remember chlorine is diatomic, so it's going to be like that. And we're going to form NaCl, which we know that is a solid. And we want to make sure this is balanced, and you can see we've got two chlorines on this side and only one over here, so we'll put a 2 here, put a 2 over here. Okay? So there's our synthesis reaction, and just by knowing what we wanted to get, we could write the entire thing. Alright, so why don't you go ahead and try this. See if you can create a reaction to form silver bromide. So see if you can do that. If you don't remember what silver bromide is, remember silver's a +1, bromine is a -1, so silver bromide would be AgBr. So that's what you're trying to create. So stop it if you haven't done it already and see if you can make that equation. Alright, so if we're trying to form some silver bromide, and sometimes, you won't know all these, but, you can have a pretty good idea of things. Typically ionic compounds, unless they're dissolved in water, are going to be solids. So you're trying to figure that out. You know a lot of things. You know silver. So you should know silver's a metal, and it's a solid. And you're going to do some bromine, and bromine is diatomic. And bromine is one of two elements on the periodic table that is a liquid at room temperature. So we would get something like that. We need to balance it. Should be something like that. Alright, this one's a little tougher. See if you can do this. Predict what will happen when we put these two together, and I'll give you a hint. Look at your polyatomic ion chart. See if you can come up with a good polyatomic ion that you're going to form. So see if you can do that. So what we're doing is trying to form, what's going to be formed from that. Okay, so if you looked it up, you might have seen, hey, there's a CO3 on there, which has a lot of the things that we have here. We've also got some hydrogens, and hydrogens tend to be a +1. And so we could put that together, and we could get H2CO3, and that would be our compound that would be formed in this particular synthesis reaction. Now the tough part of this might be trying to figure out what the state is. Well, there's water, so this is the carbon dioxide is going to get dissolved in water. This is actually going to be aqueous when this is formed. The states are probably the minor thing of these. Trying to create the product, that's the key. Alright, the next kind of reaction we're going to talk about is decomposition. Think about what that word means. Decomposition, break it down. So we're going to start with one reactant, one type of reactant, and we're going to get two or more products. So our key is one reactant. Okay? When we have one reactant, we have decomposition. So the idea here is that you're going to be able to identify, looking at any of these reactions, which type they are. So it's going to look like this. You can start with a compound. It's going to break it down often into elements again. Doesn't have to be, but that's pretty common. So this is one that didn't start with elements, or didn't break it down into elements, but we've got NH4NO3, so some ammonium nitrate, and we get some dinitrogen monoxide and some water when we're done. So this is an example of a decomposition reaction. All right, let's take a look at this one. Let's think about this. If we're going to decompose this, what are we going to get? Well, what are our options? Well, there's not a lot. There's only two elements that we've got here, magnesium and nitrogen. So it's going to turn into magnesium. Well, magnesium is just an element. It's going to be a solid, okay? And you've got nitrogen. Nitrogen is diatomic. So it's going to be like that. And then you need to balance this equation. And we'd need to put a 3 here to make sure everything was balanced. All right. So that's kind of the end of this particular part of it. And we'll pick this up in the next video.